So today we're going to look at a process analyzer, and this is, like we talked about in class, a way to make multiple runs with many parameter changes and keep track of all the output files in one location, and allows us to easily use statistical methods to draw conclusions from these results as to which type of run would be better, so which parameter changes would be ideal for the outcome of interest. So to start, we're going to rebuild the model, the walk-in clinic, represented here on the slide. So I'll just go to Arena, and we're going to build the walk-in clinic. Okay, so start with our create module. Patients arrive at according to an exponential arrival, and there are 12 minutes average time between arrivals. Alright, so I'm going to say OK. And then next we're going to have a process module for check-in. Seize delay release, we're going to seize the clerk. So the resource's name is clerk, and it's a type of resource. We're not doing a set this time. Quantity 1, and the minutes, triangular 2, 3, 5. Alright, and then next, after the patients check in, they'll then be sent to see the doctor. And this will be another resource, doctor, quantity 1, triangular minutes 5, 8, 13. And then this is a very simple walk-in clinic, so after they see the doctor, then they just go to checkout. So again, they're going to see the clerk. So here we've already used that resource name, so we can just find in the drop-down clerk, quantity 1. And this is going to be uniform distribution this time, 2 to 4 months. Alright. And after that, we'll just have a dispose module. So we're going to go to run setup to select our 10-hour replication length and 10 replications. So enter 10 for the number of replications. Replication length is 10 hours, and we're going to put base time as minutes. And click OK. Alright, so now we've got our basic model set up, and I'm going to just go ahead and run it so that we can create our .p file like we talked about in class. So we want to go ahead and run the results to create .p. So we see average number of 52 patients getting out. Then we have these basic utilizations. So we're going to recreate these results in Process Analyzer. So let's continue on with our slides. So from Process Analyzer, we get a .p file that's produced when the .doe arena files are run. And PAN is actually a separate program under the arena package. And so from arena, we can open it directly from Tools and go to Process Analyzer. And open another window, so I'll just put it here. Or you can directly open it from Process Analyzer from the Windows Start menu. Alright, so we need to create scenarios. And scenarios will be the different allocations of resources, for instance, that we want to control. So we'll have input controls chosen from variables and resource capacities. Mostly we'll think about it in terms of resource capacities, doctors, nurses, etc. And you'll fill in the number of those resources that you want to have in that particular scenario. Then you'll have a set of output responses that you're going to specify that you want to look at. So it could be total time in the system, could be waiting time, could be utilization, could be number of patients out, etc. And then when you run the scenarios, these output values are going to be filled in. So let's go ahead and create a new scenario. So you can create a new project, and we want to double click to add a new scenario. We're going to first call this a base case scenario. So then you want to browse for Actually, let me go back. I don't think I saved my arena file. So I need to first save this file. No, I need to stop it to save it first. File, save as. I'm just going to save it under documents. This was our walk-in clinic. Alright, let me run it again so that the .p file will be created. Okay, now going back to Process Analyzer. So we're going to call this the base case. Program file, we can browse for our program file, documents, and walk-in clinic is the one we just created. Click OK. Alright, so the next thing we want to do is specify the controls and responses. So to do that, we want to right-click on the scenario properties, insert control. So for our resources, we can change the number of resources for both the clerk and the doctor. So first we'll add the clerk. This is going to be an integer number. Click OK. Insert another control. So we right click to get this dialog box up. I'm going to do the doctor now. Alright, and then the next thing we want to do is our responses. So we can go to insert response. And we can do utilization and wait time, things like that. So why don't we do patient number out, so the total number they get out of the system. Insert response, total time. Insert response, patient.wait time. Oops. Get back to insert response. We're going to look at the resource, so I'm going to look at the clerk utilization, insert response, the doctor utilization. Right. So you can choose anything that you want to model based on your particular case. Alright, and so we've got to set the controls, so we're going to leave this as the base case value, one clerk, one doctor. We can duplicate a scenario, so right click on the scenario name and click duplicate. And actually you'll click on the number 1 to duplicate. So we're going to go to scenario properties. We can call this additional clerk. We're going to use the same .p file. You could actually have it where you have 2 separate arena files and 2 separate .p files, and you could choose to use different scenarios having different .p files if there was different scenarios you wanted to try out within your model itself versus just changing the number of resources. So that's also something you could do where you could change the program file that's being used. And click OK. We're going to use the same one. Alright, and then since we said we're doing an additional clerk, we need to change this resource number to 2. So we're going to have 2 clerks in this one. I'm going to go ahead and duplicate this. We're going to say additional doctor. We'll put in just the 1 clerk, 2 doctors. And I'm going to duplicate one more. Additional nurse, or sorry, clerk and doctor. Alright, so now we'll change this to 2 clerks and 2 doctors. Alright, so now we've got all of our responses and controls set up, all of our different scenarios. So then, as I said, you can use the same file or different P files from different model.doe files. You can set the controls and responses across different scenarios differently, but usually we're going to be the same. And so each row of the project table is going to correspond to a different scenario. We could save this Process Analyzer project as a .pan extension so you can refer back to it. This steps you through how to insert for each of the controls and response as we did. Alright, so now we've created all our pan scenarios that we want to run at this point. So now we can execute the scenarios. So we could select which scenarios we want to run. And I'm going to run all 4 of them and just click go. I'm going to call this, it's asking me to save it, so I'm going to call this walk-in clinic. Okay, so now it's running through the replications of each one. Alright, so we see that there wasn't much variation in the number of patients out. The patient time, total time in the system, is more dramatically changed when you compare the increase in the number of doctors, which makes sense given that the patient spends more time with the doctor than with the clerk. Patient wait time, again, dramatically decreases due to the extra doctor being added. Clerk utilization about halves, which makes sense when we add a additional doctor, and the same thing for the doctor. All right. So this allows you to quickly run several scenarios and see the key results that you want to look at. All right, so then we have patient wait time, patient total time in the system, clerk and doctor utilization. So we've all looked at all of those. So we want to make statistically valid decisions on which scenario we should use, and we want to select what we consider the best scenario. So this output column, the one you want to compare, you can go to, say, patient wait time, and you go to insert from the top menu, chart, and let's use the box and whisker chart. So we're going to do patient wait time as selected across the 4 scenarios. And we're going to check the box to say identify best scenario. And we're considering patient wait time, so we want smaller is better. And we'll leave the error tolerance alone there. So for this identifying best scenarios, you just have to look at what you're measuring and decide which one would be ideal for your situation and let the program know. I can click finish. Alright, so not the fanciest graph, but we can see the variation in the values for the different runs from this, and we can also see that the additional clerk and doctor is statistically significantly better in terms of wait time when comparing it to the other scenarios. Right. You also see that adding that additional clerk doesn't really make a big difference. If we were only comparing the additional doctor, you'd also see a significant difference compared to the base case. And the variability continues to decrease for wait time as we add additional resources. So we have the 95% confidence intervals, and then in red we'll highlight the best solution. So as I've done here, you can practice creating the box and whisker plots for the walk-in clinic example. And if you look at different criteria, you might disagree on which is the best. So in some situations, if we want higher utilization, then you could see that the third and fourth one, which had the best wait times for these scenarios, would have about half the utilization, which is not ideal. So you might pick the most important criteria or consider any limiting factors. So maybe you just don't have the budget to add a new doctor. Then the case would be, okay, should we add an additional clerk? These results would probably say it doesn't have justification for that. Or you can create a new output variable, create an expression that will have multiple objectives into one, combine the multiple objectives or outputs into one single objective, and then model your results based on that. All right. So if you had wait time and you wanted to weight that in relation to doctor utilization, you could create some function that would allow that to be in one single objective function. And we can talk about some examples of that if you're interested for your projects. As I mentioned before, OptQuest is another add-on program for Arena that will systematically search for all optimal solutions within your models. You would describe your optimization problem in OptQuest and let it search for the controls that maximize or minimize your objective as desired. Much of the same functionality is able to be achieved in PAN. You just have to go through a little bit more effort setting the program up, setting up your scenarios. So you can go back to your ED assignment and use PAN to look at different scenarios for the resources. And so we'll start back with this example when we meet next time.